All right, 6 cosine squared x. 6, much better, minus 7 sine x minus 1 equals 0. When I have a problem like this, and by the way, I'm still looking at this. I'm not looking at all of them. I'm only looking at this, 0 to 2 pi.
So you can be like that for all of them, you think?
Yes. We're not going to have to worry about all that other stuff. I cannot do anything with this because I have some cosine and some sine. So is there a way that I can change everything to sine or everything to cosine?
Yes.
I can change, instead of cosine squared,
1 minus sine squared x.
okay, so I have 6 times 1 minus sine squared x minus 7 sine of x minus 1 equals 0. Can I get rid of my parentheses?
Yes.
So I have 6 minus 6 sine squared x minus 7 sine x minus 1 equals 0. I need to get this in the right order and combine what I can combine. Is that right with you? So I have negative 6 sine squared x minus 7 sine x plus 5 equals 0. Are you guys okay with this? Factoring it? Okay, hang on. I don't like this because I don't like factoring when my first term is negative. I think it's easier with it being positive. Yes, Lily?
Can you just take out a negative sine x?
Can I just multiply everything by negative 1?
Yeah.
Sure.
Because I feel better if that first term's positive. Okay? So I have 6 sine squared x plus 7 sine of x minus 5 equals 0. Right? Now, to factor it, what do I need numbers that multiply to? And add to 7. You agree? Negative 3 and 10. What do I do with those numbers? Put them over 6. And what? Reduce. So I have 2 sine x minus 1, correct? And 3 sine x plus 5, right? Y'all agree?
Yeah.
So for the first one, what is sine of x equal to? What quadrants is that going to happen in?
1 and 2.
1 and 2. Do we agree? And it's 1. That means this is 1, this is 2. What is this?
Radical 3.
No.
Oh, that. Oh, sorry. I was. Yeah.
Pi over 6. So x is pi over 6, and what else? Quadrant 2. Do you all agree? Now for my second piece, Does this say sine of x is negative 5/3? Where does that happen? Why? Because it's bigger than 1 or negative 1? Well, but it's because it's
greater than 1, or negative.
yeah, it's actually less than negative 1. It is not between negative 1 and 1. How's that? So we throw this one out. So that's my answer. Did you get a little confused there? Kind of trying to pick up a lot of variety of them, okay? What? That one was long? Two cosine x minus 5 equals 3 secant x. Right? What?
Or you could, do you want to get them all over one side?
Well, I will in a minute. First of all, I'm going to try to get them to the same trig function.
So you want to change secant to
Is it 3 over cosine?
Uh-huh.
3 over
So 2 cosine x minus 5 equals 3 over cosine x. The problem here is that I can't work with a cosine in the denominator. So can I multiply my entire equation by cosine x? When I do that, multiply this whole thing by cosine of x, it gives me 2 cosine squared x minus 5 cosine x equals 3. Get it equal to 0. Okay. What are my numbers? So would it be negative 6 and 1? Negative 6 and 1, each of them over 2, right? So I have cosine of x minus 3 times 2 cosine of x plus 1. What? Where did what cosine go?
The cosine squared and cosine. Well, it went into,
Well-
now it's cosine squared. 5. Saying it's not cosine.
Yeah.
Yeah.
Okay, are we back here? So this one is cosine x is 3. This one is cosine x is negative 1/2. Right? Can cosine be 3? You know, you're going to get to where you're like, okay, I'm so glad I can just mark that out and not mess with it. It's gone. Now, cosine x is negative 1/2. We know that's in 2 or 3. This is negative 1. This is 2. What is my angle?
5 pi over 3. Or wait, I mean, 2 pi over 3.
2 pi over 3?
Yeah.
Or 5.
Are we good? How was that one? Was that better than the last one?
Yeah.
Maybe.
Ooh, last one more.
What? I thought she had people in there to help her today. Cosine 4x minus cosine 2x equals 0.
Let's put the identity names.
Yes. Now, we have an identity for cosine 2x, don't we?
Wait, do you want to do that identity or do you want to do the sum to product?
Okay, if I do sum to product, doesn't it put cosine minus cosine? No, it changes everything to sine, doesn't it? What I want to do is I want to make sure I don't change it to two different trig functions. I don't want to change it if it has sine cosine. Does that make sense to you? So let's try it. I don't know if it'll help or not. Let's try it. What is it? Negative 2 sine what?
6 over 2, 6 sine 3.
Does that help us to go to sine 3x?
No.
Not really, does it?
I would rather us do.
So let's think back. That didn't look good. Is this the same thing as this?
Oh. That's not.
Do you agree? So can I change it? Can I use a double angle?
Yeah, I'm also a little confused on this.
Yeah, but how do we get that? How do we get 2
Yeah.
times 2x?
Is 4 2 times 2?
2 times 2.
That's all I did.
Oh, that. Oh, okay.
Let's change 4 to 2
Oh, I
times
thought
2.
you were condensing the whole.
No. I only did that first piece.
Yeah, I was like, how
I know,
do
yeah,
we
I was
get
like,
a 2x
wait a
and
minute.
a 4x?
No. You okay with that? Now, what I want to use, are you looking at double angles?
Yeah.
For cosine 2x, can I change that to 2 cosine squared minus 1?
Yeah.
So this piece becomes 2 cosine squared 2x minus 1. Minus 2 cosine squared x minus 1.
Oh, I see. We didn't have to break it down into 2 times 2x, did we?
Well, I wanted you to realize it was a double angle. It's a double angle, yes. Do you agree? So, could I change this to 2 cosine squared x minus 1? Ooh, that's going to get ugly. Squared
is it
Wait, why are you squaring it?
Because there's two of them.
Because they're squared right here.
Put the square, we already put the square.
Because this,
That whole thing is square.
the whole thing is squared.
Yeah, but there's a square. That's the formula.
That's the
Cosine
formula.
2x is 2 cosine squared.
This cosine 2x is the same thing as this. So I took this and in place of cosine 2x, I put what it equals, and the whole thing is squared.
I don't like this problem.
Minus 2 cosine squared x plus 1 equals 0. Right? I thought the other one was a log problem. So this is 2. Huh?
So I had no problems with the other two problems. Those were my major.
When I square this,
Did you like foil that? Or no?
I can foil it, but I'm going to take the shortcut. Don't we have a shortcut?
Please.
I hope so.
Oh,
Which is square the first.
square the first and then.
Wait a minute. What's next? Multiply the 2 together times 2. Square the last.
That's just time. Yeah, that's what we're doing. But she said she was taking the shot. Instead of writing them both out and doing first, outside, and
I was like, that's just how
Then
you
add
factor
it.
equations, right? How does it?
Yes, but I still have some that want to write it all the way out, Chandler.
I usually write
Well,
it
I
out.
choose to write it all out, but I mean, it's.
I get scared that I do something wrong and then.
So now, I know that I still have all of this. So do I have 8 cosine to the 4th x minus 8 cosine squared x plus 2 minus 1 minus 2 cosine squared x plus 1 equals 0.
Why is there?
Wait, where did we get the?
Where do we get the other negative one?
Whoa!
What other negative
Oh,
1?
that's been up there this whole time.
I do not see that.
I couldn't see it either.
So we should combine like terms.
Yes. So I have 8 cosine to the 4th x minus 10 cosine squared x, right?
And then 2
Plus 2?
plus 2. Can you factor?
Yeah. What multiplies to 16 adds to negative 10. Negative 8, negative 2, put them over 8, right? So I have cosine squared x minus 1 and 4 cosine squared x minus 1, right?
Yeah. Oh my goodness.
Okay, here I have cosine squared x equals 1. So what does cosine of x equal?
Plus or minus.
Plus or minus 1. Right? Here I have cosine squared x equals 1/4.
So like it's really just plus or minus 1/2.
So cosine of x equals plus or minus 1/2.
Wait.
I square rooted it.
Oh, yeah.
Okay. look at your graph. Cosine of x. When is it 1?
On an axis.
When is it 1? Is this the cosine graph?
Yeah.
Yeah.
Where is it 1? At 0? When is it 1? Negative 1? No.
Negative 1 is high.
High. Now, when is cosine 1/2?
So that'd be a pi over 3 thing. So pi over 3.
Wait a minute, do I need that in every quadrant?
Yeah. Oh,
Yeah.
So pi over 3. What's next? And 5 pi over 3? Wow. You don't like that problem?
yeah.
Bad news.
Not at all.
Are we gonna
What?
have any?
Bad news.
You're probably not going to like the next one either. What?
So we're gonna have problems like this on our.
Yes, ma'am.
I feel like we did so much extra work though, you know?
What did we do that we didn't have to do?
I don't know. Easier way. Yeah.
Just too much,
Yeah.
okay.
Is there not an easier way to do that one?
No, no. Well, I could have shortcutted a lot. I would have shortcutted a lot.
Well, yeah. Yeah.
I hope you screwed up.
Yes.
Fairly. I don't think it will be as long as that last one. All right. We have 2 trig functions. I need it in 1 trig function, right? There is no way to change sine to cosine or cosine to sine without, we're going to square both sides. Because I can change a sine squared or a cosine squared, can't I?
Yeah.
Yeah.
So when I square the left, square both sides, isn't this 1 minus 2 sine x plus sine squared x? Right? What do I get when I square the right? Don't, I'm just squaring it. You're right. But it's going to be, isn't this going to be 1 minus sine squared x? I need to get the problem equal to 0. All right? So don't I need to move this over here? When I move this over here, how many sine squareds do I have?
2.
So I have 2 sine squared x. Okay? Minus 2 sine of x equals 0. Agreed? What am I going to do with this? I can't factor it into 2 sets of parentheses.
Oh, you can pull out 2 sine x.
Can I factor out 2 sine x? When I pull out 2 sine of x, I am left with sine of x minus 1. Right? You agree? So don't I have 2 sine of x equals 0, or sine of x equals 1. Oh, that should say 1, shouldn't it? All right, let's look at the sine graph. Look like that. Here, if I divide by 2, isn't sine of x still equal to 0?
Yeah.
Okay, tell me, looking at the sine graph, when is sine 0? X equals 0, and when? What? Pi. Now, when is sine 1? And? Is that it? Okay, here's my 3 answers. Now, the problem. Anytime you square both sides, you can get what's called extraneous roots. Answers that don't really work. So anytime you square both sides, you have to check your answers. Okay? Now remember, my original problem was equals cosine of x. So, what's the sine of 0?
0.
So 1 minus 0 equals, cosine of 0 is 1. So that one works. Now let's try pi. What is the sine of pi? What's the sine of pi?
0.
What's the cosine of pi? Does that work? No? All right.
Where did teaching not work out here?
What?
Along with pi.
It didn't work. 1 minus 0 doesn't equal negative 1.
You asked him if she was understand. I was just looking at, I was like, where's the work? And I was like, where did it go?
Now I'm going to put pi over 2 in. What's sine of pi over 2?
Sine of pi over 2 would be 1.
1? What's the cosine of pi over 2?
0.
So,
She's checking our work.
I'm just...
I know what she's doing. That's what I'm trying to do. But like,
Okay, Chandler, why are you confused?
Okay, so it's 1 minus sine of x, x equals pi.
What's sine of pi?
Negative.
Sine of pi is 0. Right? So I have 1 minus 0. What's the cosine of pi? So 1 minus 0 equals negative 1? Is that true? No.
Oh, yeah, no. I'm just, it wasn't like I was confused on how it made sense. I was trying to figure out what I was looking at.
Okay.
I like couldn't.
We're looking at these 2 graphs. Are we good?